Hello, hello, hello! Welcome back. It is Sunday, a rare Sunday one. Sunday, the 15th of February. And today we are going to go through a live solve of paper 2 of not last year's, but 2024's Edexcel A-Level Math series. I did paper 1 the other day. I think it was actually really good to demonstrate not just conceptually how to get through the different questions, but also what are the tips and tricks I use to make sure I'm executing correctly and using a good exam technique to make sure I'm getting every available mark. So one thing I liked that I did last time that I'll do again this time is the way I went and checked my work after I was done. So we got someone in the chat saying they missed the last 3 weeks of stream. Discord server nearly out. I have my account. I kind of set up a server, but then one of my students said that he'd also set up a server, which apparently is like, got all the bells and whistles in it. So server is definitely going to be out this week. I know. Discord is apparently a thing. So yeah, Discord server definitely coming. You've asked for it. It is definitely coming. It's launching certainly by the time of my next stream, one way or the other. So either I'm going to look at the one that my student set up and go, this is phenomenal, this is perfect, just add me as an admin and let's get this done. Or I'll look at it, use the one that I set up on my own and kind of get that done. It's been a little bit slower than I'd anticipated. He was a little bit busy this week, but yes, Discord server coming. No worries about missing the last few weeks of streams. You can feel free to jump in wherever you want. And I'll make sure that you sort of, whenever you are here, you can ask your questions and get your sort of benefit out of it. I am talking to you. Oh, apparently I can ask my... Oh my God. So apparently I can ask the student to transfer ownership to me. That is interesting, and I will bring that up with him when I chat to him after this stream. Now, in the meantime, what I'm going to do is I'm going to do a live solve. I'm going to be a little bit less in the chat. I think what I'll probably do is I'll finish a question and then dip in the chat just to make sure I'm not getting any spoilers. So if you guys feel free to chat to each other, but try not to like do the questions with me because I want to do this blind unseen as much as possible. Main 2 things we're going to go through, ways in which I execute accurately during the run, and then after the run, how do I check my work in order to make effective use of what time I have left before time runs out. So rather than redoing the questions, as I see a lot of students do, how can I plug in numbers on both sides and really test quickly if it's absolutely correct or if there's something I need to do to find a mistake? Okay, so without further much, I can't even speak. Without too much further ado, let's get into it. So I'm going to share the window. Just checking to make sure. Yep, you can see this well. Am I going to time it? Great question. I think I'm going to loosely time it, but I'm not going to hold myself too much to the timing. I think what I'm going to do is, let's set a timer for 2 hours. My plan is to go through a little bit more slowly, explain my reasoning as I go rather than rush through it. So you can kind of get it one and done, and then you can kind of come back and check for any corrections after the fact. All right, so I'm 2 hours on the clock. I think it's 2 hours. Yeah, so I'm allowed 2 hours. I should hopefully not take that much time, and I'm just going to get going. Let's start the clock. Right, so we have this function. Where's scroll function? Oh, no, that's fine. So, okay, find the simplest form, dy dx. So we're starting off nice and simple. Part 1. Dy dx, this is fairly basic. It would be 12x squared minus 14x plus 5. And for part 2, differentiate that one more time, and we're going to get 24x minus 14. That should hopefully be fairly standard for you guys. Hence, find the exact value of x when this thing is equal to 0. Well, for part B, we're going to set that equal to 0, which means that 24x is equal to 14. X is equal to. Now, do I need this? No, but I'm trying to make sure there's no chance of a silly execution error. So I will use the calculator and say that x is equal to 7 over 2. The end. Great. Did not need all that paper. I'm also not going to present my work in the best way, just to make sure I can keep the question and my working on the screen at the same time. So yeah, hopefully it won't look too bad on the screen. And I would zoom into the question a bit more, but I want to make sure there's at least enough working space as well. So Jamie takes out an interest-free loan of £8,100, makes a payment every month to pay back the loan, repays 400 in month 1, 390 month 2. Okay, so we have an arithmetic series going on. Show that Jamie, okay, so what we have is, we know with any arithmetic series, the most important things are A and D. We know that A is equal to 400. We know that D is equal to minus 10. So in month 12, well, UN is equal to A plus N minus 1D. So month 12 is equal to 400 plus 11 times minus 10, which is 400 minus 110, which is equal to 290. Good. I'm going to do B here. After the nth payment, the loan is completely paid back. So that is the sum to N is equal to 8,100. So we have 8,100 equals N over 2 into 2A plus N minus 1D. And we can expand all this out. Or in fact, yeah, so let's expand this out. So that becomes 400N minus 5 into N minus 1, which is 400N minus 5N. You can't see this because my face is covering it. N over 2 into 2A plus N minus 1D. Plus 5 is equal to 395 N plus 5. Oh, no. I'm telling complete lies. Apologies. I'm forgetting that the minus 5N into that stuff. So that becomes 5N squared plus 5N. So that is minus 5N squared plus 405N. 5N squared plus minus. No sign errors today. I mean, you'll see this, like sign errors. My brain is so bad with that. So minus 405N plus 8,100 equals 0. N squared. Let me just confirm explicitly that when I divide these numbers by 5, I get the numbers I want. 8,100 divided by 5 is, 1620. Good. So we've got that quadratic, hence find the value of n. Well, if n squared minus 81n plus 1620 is equal to 0. Oh, am I going to find a factor pair? It kind of looks like it. Well, I know it has to be an integer. It has to be a whole number. I'm going to have some fun and find the factor pair. So 1620, I know that's going to be 20 into 81. Let me just check that. So yeah, so it's 20 into 81. Okay, so we don't like that. So let's take a 3. They differ by 81. So they have to be slightly more different. So why don't I say it's 15 and 108. So it's 15 times 108. The difference between those is, okay, screw it. This would be wasting too much time in the exam. I'm just going to have to use the formula. So n is equal to minus b plus or minus square root b squared minus 4ac all over 2a. So 81 plus or minus the root of. Now, 81 squared minus 4 times 1620 is 81. So it's 81 plus or minus 9 over 2. So when I subtract 9, I get, well, I'm just going to do it like really sensibly. So it's n equals 36 or n equals 45. Now what I want to do is work out. Now why? Okay, so why are there two? So what I should do is work out. Oh, interesting. Okay, so. Oh, of course, they were both. Sorry. They were both in the same direction. Okay, so we have two of them. Why would. Because they're going down. Why should there be two, though, if they're going down linearly? All right, I'm just going to plug them both back into the series sum. So if with the first one, when n equals 36, the sum to 36 is equal to 36 over 2 into 2a plus n minus 1d, where n minus 1 would be 35 and d is minus 10. So let me just plug that in and make sure I get the right number. So 36 over 2. Now, realistically, I might skip this and come back to it under time pressure, but I just want to, it equals 8100. And the sum to 45 is equal to 45 over 2 into 800 minus 44 lots of. So 45 over 2 into 800 minus 45. Oh, I understand what's happening. Right, so we want the first one, because what's happening, I've missed the fact, yes, these numbers are going down, but the sum is going up, and then eventually it becomes so negative. What we need is for the terms themselves to be positive. So the reason why is because you're doing it, and then you're bringing money back out again, so it comes back down onto 8100. Apologies for not getting that sooner, but it is definitely n equals 36, the first month where it hits the total. Also, obviously, as the first time he hits the 8100, it's paid back, so he's not going to carry on to month 45. Okay, apologies for not keeping my head on that one, but you just got to get through to the right answer at some point. Anything in the chat? Okay, nothing. Okay, let me see if I can. Well, how am I doing on time? I should try and pick up some time, because well, in fairness, this has only been 10 minutes. Whatever, it's fine. So we have a point lying on a curve. Find the coordinates of the point where it's mapped. Okay, so this first transformation, we know that's going to map it 2 to the right. So that's going to turn it into 5 minus 2. I'll probably come back and explain this after the fact, but this one's going to become 3 over 2 minus 2. And then part 3. Okay, let's go through this sequentially. F of minus x would send it to minus 3 minus 2. I would then be tripling the y coordinate to minus 6 and adding 5 to minus 1. So that's my answers on that. And I will explain, there's like a whole sheet I have for graph transformations to make your life easier. And I'll also emphasize at that point, in fact, I'll make a little note to myself to come back and explain that one again. Because there's a lot I have to say about graph transformations while I'm here. Cool. So we got a sequence defined by this. It's an iterative sequence. All right, this is going to be fine. In fact, I'm just going to do this on here just because I want you to have the question and to see my working as well. So what I would do here is to say if u1 is equal to 6, then u2 is equal to 6k minus 5. And u3 is equal to that times k, which is 6k squared minus 5k minus 5, which is equal to minus 1. And then moving that to the other side, we get minus 4 equals 0. Perfect. Hence, find the value of k. Since when is Discord server being made? Since people have been asking me for it forever. Right, so minus 24 is my target number there. I might go through this if people need it. And so I need numbers that multiply to minus 24 and add to minus 5. In fact, yes, I will absolutely talk about that as well, because there's a really cool method from the IB that people might prefer for this. Now, so what they're going to be is it's going to be minus 8 and plus 3. So the plus 3 is going to come from 3k plus 1, and the minus 8 is going to come from 2k minus 4. So those will equal 0. So k is equal to 4/3, or k is equal to minus a half. K is a positive constant, so k is equal to 4/3. And find the value of the sum from 1 to 3. So all we have to do here is to plug them back in. We know that U1 is 6. U2 is going to be, when I plug that back in, 6 times that is going to be 8. But why take any chances? Multiply by 6, subtract 5, I get 3. And we know that U3 is minus 1. So the sum from 1 to 3 is going to be 6 plus 3 minus 1, which is 9 minus 1, which is 8. Okay. This. Small angle approximations. Okay. So the small angle approximation, come on, just drag. The small angle approximations we need are, so tan 2 theta will become approximately equal to 2 theta. I know that cos 3 theta will become approximately equal to 1 minus thingy squared over 2. Is it all over 2? No, it's this one. Which is equal to 1 minus 9 theta squared over 2. So when I plug that all in, I'm going to get theta times 2 theta all over 1 minus 9 theta squared over 2, which will become 2 theta squared all over 9 theta squared over 2, which multiplying top and bottom by 2 will give me 4 theta squared over 9 theta squared, which is obviously equal to 4/9. Great. Ooh, more graph transformation. No, not graph transformations. Boo. Just got to differentiate. Again, this is going to be really annoying. So I think I'm just going to annotate on the question itself. So we have these graphs. Let me zoom in a little bit. If we have these functions, then f of x I'm going to differentiate using the chain rule. So that is going to become 8x e to the 4x squared minus 1. Differentiate this, I'm going to get 8 over x. So remember, with the chain rule, it's d big, d small. So if I differentiate 4x squared minus 1, I'll get my 8x. And then let's do it explicitly. So if u is equal to 4x squared minus 1, then du dx is equal to 8x. And y is equal to e to the u, so dy du is equal to e to the u, which is why the whole thing is dy du du dx, which is 8x e to the u. Now, similarly, whenever I'm differentiating ln, I will always do differential over original. The differential of x is 1, so it becomes 1 over x times the original 8. So given that these two things are equal at x equals alpha, show this equation is true. So 8x e to the 4x squared minus 1 would be equal to 8 over x. I'm first going to cancel the 8's. And I'm going to say that x squared e to the 4x squared minus 1 is equal to 1. But that's not what they want. So I will say that e to the 4x squared minus 1 is equal to x to the minus 2. 4x squared minus 1 is equal to ln of x to the minus 2. And then using my log laws, that's minus 2 ln x. And then bringing that across, we get this equation. Good. Is there any step of this I need to explain a bit better? I've divided by x squared here, so 1 over x squared is x to the minus 2, then taking natural logs of both sides, and then rearrange. Okay. You have an iterative formula is used with x1 is equal to 0.6. Find an approximate value for alpha. Calculate giving each answer. Okay, so x2. Now, there's a really cool tip on this, which is just to use your answer function. Now, okay, this is incentivizing me to maybe get the emulator, but all of you have different calculators, so maybe not. Whichever I'm gonna dictate out loud what I would do, and I'm hoping that you have your calculator handy and you know how to achieve this on your particular handset. What I'm going to do is I'm going to type 0.6. Now, some of them you can explicitly store answers. Some of you can't. This calculator, you can't. I'm going to type 0.6 equals to store it in my answer button. Then I'm going to do root of 1 minus 2 ln answer, close bracket, over 4. And if I type equals, that will give me x2 very explicitly. So x2 is 0.7109 to 4 decimal places. But the very helpful thing about doing this is that is now my new answer. So when I press equals again, it will just put it back in and get me x3. So x3, if I just press equals again, I'll get 0.6485. Now, conceptually, I'm just going to keep on pressing equals until my answers agree to 4 decimal places. So 6830. The next one is 0.6638. Then I get 0.6745. Then I get 0.6685. Then I get 0.6718. You can't see this. This is unhelpful. I really hoped it would converge a bit quicker. X9 is 0.670. Oh, God. Let me show you exactly what my calculator says. My calculator says 0.669986, which then when I do that to 4 decimal places would be 0.6700, which is an unhelpful rounding, but we're getting closer. Next one, 0.6710, getting closer. X11, 0.6704. And honestly, at this point, I think you get what I'm doing. I'm just going to keep going. I got, in fact, the next ones I got 0.670. Oh, bother. Did I? No, I'm just going to run this back. I pressed it too many times, guys. All right, 0.6 equals. So this was not a failure of my math. This was a failure of my commentary skills. Over 4. So run it forward. So that one, that one, that one, that one, that one, that one, that one. Yep, yep, yep. Okay, the next one was 6708. The next one after that is 0.6706. Then it's 0.6707. Then it's 0.6706. Then it's 0. Come on, get there faster. Oh my God. All right, I have to just keep going until it converges. Right. We finally, the next one is 0.6706. Okay, so we have 2 that have converged, and now they're just going to be 0.6706 all the way through. And so that is the answer, 0.6706. That would have been impossible if I had to keep typing it out. So yeah, just have the answer button ready. No! You're You're so right. The number of times this question made me say 6, 7. They didn't know. They did not know in 2024 the scourge that they had wrought on the earth. Ugh. No, don't clip it. Have your fun. All right. Cool. Question 7. Okay, so figure 2 shows a sketch of a straight line L. It goes through A and B. We have vectors, HB. Right, vectors for me is all about what I call pathing. So I know it's not like, you have a very easy way of doing this, but I always insist on good pathing. So I will say that this is equal A to O and then O to B, where A to O, this position vector is O to A. So its position vector is from origin to point, and so this would be O to B. So A to O is the negative of this. So it's negative 2i plus 3j. So just swap the signs around, minus 5k, plus 5i plus 6j plus 8k. So this would be equal to 3i plus 9j plus 3k, and that's AB. Given that a point lies on L such that the magnitude of A, okay, so P, so the distance from A is twice the distance from P. That's how I interpret that. The distance from A is twice the distance from B. So the easy one to see is where it is simply 2/3 of the way along the line. And the other one is going to be over here. The other one's going to be over here, where that distance will be twice that distance. So it will happen when it's equal to AB and then again. So I can kind of see this in my mind's eye, but no Discord server link yet. It's coming. Don't worry. It should come today, tomorrow, like some point this week. So I can see this in my mind's eye, but let's do this algebraically. Let's just get the generic. So the generic point, let's call it ABC. Why not? So let's say that P lies at the point ABC. Then the magnitude of AP will be equal to A minus 2 squared plus B plus 3 squared plus C minus 5 squared from 3D Pythagoras. Well, that's squared. And we know the magnitude of BP squared. Am I going to be doing this fully algebraically? Let's find out. So it would be A minus 5 squared plus B minus 6 squared plus C minus 8 squared. And we know, because I would really like a nice algebraic solution here. A minus 2 squared. We know that this guy, so if I square all this up, that squared would be equal to 4 lots of that squared. So if I plug this in, this does not look like it's going to be fun. No, wait, I'm doing this so wrong because of course it lies on the line. What am I doing, guys? This is stupid. I'm doing stupidity. As long as I can, I have done silliness on this day. No, okay. Okay, so I should not have called it ABC. We can get an equation for a general point on the line because we know that is AB. So that is the direction vector of the line. So we know that a general position vector on the line, is this getting a bit into A-level further math? Maybe. I'm going to run with it anyway. So the general position vector for a point on the line, so we know that OP is equal to OA plus AP. And because P is on the line, it means that AP must be parallel to AB. So that must be OA plus some lot of AB. Discord link is going to be posted in the community tab. Absolutely. I will also post it in the descriptions of my videos so people can find it easily from wherever they're kind of getting my content. So we know that OP, the position vector of P, is OA I'm just going to do this as column vectors because I cannot be bothered with i's, j's, and k's anymore. Plus some lot of 393. Okay, so that is equal to 2 plus 3 lambda minus 3 plus 9 lambda 5 plus 3 lambda, and that is OP. So then A to P, to get from A to P, because A was, well, we know A to P, it's just lambda AB. So AP is equal to 3 lambda, 9 lambda, 3 lambda. And I kind of want to do this intuitively, but I want to find a nice algebraic path. Right, so AP is this. What is BP? It's equal to BO plus OP. So BO is minus 5, minus 6, minus 8, plus this guy. 2 plus 3 lambda, minus 3 plus 9 lambda. I could just tell I'm not finding the efficient path here. So it's 3 lambda minus 3, 9 lambda minus 9, 3 lambda minus 3. Huh. Well, would you look at that? Because AP is equal to 3 lots, I'll call it 3 lots of lambda, 3 lambda, lambda. And BP, I'm sure this is not a coincidence, is 3 lots of lambda minus 1, 3 lambda minus 3, lambda minus 1. No, so I could have, Okay, I apologize. I'm sorry. But this is what it is. This happens. Sometimes you don't find the good path. It's because I am going to take the 3 lambda out. Now, realistically, you should skip if you find yourself stuck in the mud as much as I am right now. But I just think this is very interesting because AP is 3 lambda times that. But if I take a 3 lambda minus 1 out, washed. How dare you, sir? How dare you? I will find you. Because what that means here is, given that the magnitude is 2 times the magnitude of that, what that means is, so the magnitude of AP here is going to be 3 lambda times the square root of 1 plus 9 plus 1. So it's 3 lambda times root 11. And this magnitude of BP is going to be 3 into lambda minus 1 into root 11. And this is double that. So 3 lambda root 11 is twice 3 lambda minus 1 root 11. And obviously the 3 root 11s cancel. So lambda equals 2 lambda minus 1. And this should have given me 2 lambdas. So I should have got quadratics here. No, okay, I should have. All right, we're doing this the intuitive way. Sorry about it. I'll see the alternative path. I saw it for initially, so I'm just going to do this. Right, so we know that A to B is equal to 3, 9, 3. And your starting point here is at 2 minus 3, 5. I'm going to do what I saw initially. I know that this is, if this distance is double that distance, it's going to be 2/3 of the way along that. So it's going to be 2 minus 3, 5 plus 2/3 of the 393, which means it's going to be equal to 2 minus 3, 5 plus 262, which is equal to 4, 3, 7 is the first point. Now this point here is going to be equal to 2 minus 3, 5 plus 2 lots of the 393. So that's going to be 2 minus 3, 5 plus 6, 18, 6. So it's going to be equal to 8, 15, 11. Let's see if I can come back. So I got intuitively that the two lambdas I wanted were 2/3 and 2. Let's see if I can come back and find a proper quadratic for that after the fact in question 7. But I'm sure that's the right answer. Apologies for using an intuitive path, but time is of the essence. Can't be wasting it on, I've already spent half an hour. Oh, yes. Love a good, what's it called? What's this? What is this? This is trigonometric identities. Love some good trig identities. Now, when you're doing trig identities, you are doing one of three things. You are using what I would call reducing to base functions. So reducing everything to sine and cos in the hope that things cancel. You're using an identity to convert one trig function into another, or you are using algebraic fraction skills. And so let's look at this. So let's start, and you always start with the more complicated end and work towards the simpler end. So in this case, I'm going to start with 1 over it. Now, because I'm copying down, let me make absolutely certain that I do not copy it down wrong, which is easier to do than you think. All right, so I'm going to bring these to a common denominator. So I'm going to do cosec theta. I'm going to multiply the left fraction by cosec theta plus 1. So cosec minus 1 times cosec plus 1, difference of 2 squares. That's cosec squared theta minus 1. And this would be cosec theta minus 1 over the same denominator, multiplying top and bottom by cosec minus 1. And on the bottom, you will get cosec squared theta minus 1. So this is clearly equal to 2 cosec theta over cosec squared theta minus 1. I want to get that into tan sec. Well, I know that my sort of linked trig functions are sine cos, sec tan, and cosec cot. And I can never be bothered to remember them. So if I start from sine squared plus cos squared equals 1, then divide through, cosec is 1 over sine squared. So 1 plus cot squared equals cosec squared. And cot squared equals cosec squared. Now, is it, should I have thetas in here? Yes, I should. Whatever, it's fine. So I got my cot squared equals cosec squared minus 1. I have absolutely no shame about the fact that I've never bothered to memorize those. Now I'm going to reduce this to base functions because we can see this is in tan and sec, and this is sort of cosec cot. Let's reduce this to sort of put everything in terms of sine and cos. So that is 2 over sine theta divided by, now cot squared is 1 over tan squared. So because I want a 10 on the top, I'm actually tempted to keep it as 1 over tan squared for now. Because then I can multiply top and bottom by tan squared, and it would be 2 tan squared theta over sine theta. Now let's reduce this into sine and cos. So that would be 2 sine squared theta all over sine theta cos squared theta, where one of the signs would cancel. And I'm going to write that as 2 brackets sine theta over cos theta times 1 over cos theta. I do not know why this strobing is happening. Apologies for that. So that is 2 tan theta sec theta. which is what they wanted. Great. Okay, cool. Hence solve an equation. So B, hence solve. Now, the important thing to note, there's a couple things. First of all, theta has turned into 2x. So I want to solve this for 2x. Very first thing I'm going to do is transform this interval. So what we have is this thing on the left will become this thing here on the right, where theta is now equal to 2x. So 2 tan 2x sec 2x is equal to cot 2x sec 2x. Cot 2x sec 2x. All right, the very first thing I'm going to do is check to make sure I've actually copied this down correctly. So 2 tan sec equals cot sec. Good. Right, now I'm not going to divide by sec 2x because I might lose solutions, except actually I know that sec never does actually have solutions. How many marks is this? 4 marks. I'm gonna bring this all to one side because I like having trig equals number. I'm going to reduce these all to base functions again. So this would become 2 sine 2x over cos squared 2x minus, now cot is cos over sine. So that's cos. Oh yeah, I really should, let's work on that first. Let's work on that first. So I'm not going to touch the left-hand side for now. I'm going to touch the right-hand side and say that that is cos 2x all over sine 2x times 1 over cos 2x, because then these will cancel. And that very simply becomes 1 over sine 2x. So in other words, 2 tan 2x sec 2x sine 2x is equal to 1. And if I reduce that to base functions, I'll get 2 sine 2x over cos 2x times 1 over cos 2x times sine 2x equals 1. Okay, I can see where this is going now, because that is going to become sine squared 2x all over cos squared 2x is equal to 1/2, which means that tan squared 2x is equal to 1/2, which means that tan 2x is equal to plus or minus 1 over root 2, which is great. Now I'm working in degrees, and I'm working for 2x between 0 and 180. So the first answer I know is going to give me 45, but I'm going to verify that. 1 over root 2. Oh, I got that dead wrong. This is why you verify, guys. No, the cos of 1 over root 2 is 45. I know. This is why we verify. Okay, so the first solution I get, so let's solve them separately. So if tan 2x is equal to 1 over root 2, that means 2x is equal to 35.3 degrees. No, 1 decimal place. If I want my answer correct to 1 decimal place, I must round every interim answer to at least 2. Now, I also know that the next value of 2x would be, so you get for tan, you get a value every 180 degrees. So I know the next one up would be that plus 180, but that would take me outside my interval of 0 to 180. 0 to 180 means we're only going to get one solution for each tan equation. So on the other side, I'm going to have tan 2x is minus 1 over root 2. So 2x would be equal to, you guessed it, minus that thing. which is obviously not in the interval. So to get to the next one, I have to add 180, and I get 144.74. So these are my two that lie in the appropriate interval, and then I divide both by 2. So for the first one, I'm going to get 17.6 degrees, and for the second one, I'm going to get 72.4 degrees. And those are my answers. Right, let me zoom out a bit so I can see what's happening here. Path of a small ball travels in a vertical plane, thrown from the point represented by A, caught at B. This looks quadratic-y. The height has been plotted against distance with respect to an origin. We know the coordinates of A and B. We know the max height when x is equal to 9. That's important because that looks like vertex form. Find h in terms of x, because it's a quadratic. Okay. What form do we know this thing takes? We know this is going to be of the form there's a couple of ways to do this. We can either do vertex form or we can differentiate the general quadratic. I'm tempted to use vertex form. The fact that we know that the maximum is at x equals 9 means it must be of the form x minus 9 squared. We know it's negative. You stretch it by a, generally speaking, plus b. So this is general vertex form. What I'm going to do now, and I'll probably demonstrate the other way as well, but this is the way I'm seeing. What you can then do is substitute in the known coordinates to work out what a and b must be. So when x equals 0, y equals 2, tells us that 2 is equal to minus 81a plus b. And we also know that 0.8 is equal to minus 121a plus b. If I subtract top minus bottom, I get 1 point. Now, I should really not be doing as much mentally as I am, but hey-ho. So 121 minus 81 is equal to 40a. So a is equal to 1.2 over 40, which is 0.03. Plugging that into the first equation, b is equal to 2 plus 81 times 0.03, and I get 2 plus 81 times 0.03 is 4.43. So it looks like it's of the form. Give h in terms of x. I'm going to say h is minus 0.03 x minus 9 squared plus 4.43. Can I be bothered to multiply this back out again? No, I'm going to stick with it. Give one limitation of the model. I'm going to say ignores air resistance. I think it wants that, because I'm thinking it could be something. No, if it's caught there, then it's fine because it won't go negative. Standing directly under the path of the ball at a point 16 meters horizontally from O. So that's when x equals 16. She can catch it if it's less than 2.5 meters. So let's, for C, just plug in h of 16 would be equal to minus 0.03 into 7 squared plus 4.43. So it's 4.43 minus 0.03 times 49, which is 2.96, which is bigger than 2.5, does not catch. I'll write that down as a one to check to sort of redo the other way, just to make sure my answer corroborates. Parametric equations I adore. Show that the tangent to C at P has this equation. Well, let me just write this down because I'm going to need to scroll down. So x is equal to t plus 3 all squared. Y is equal to 1 minus t cubed. This slice I see. Now, this is important because that means that t is equal to minus 1. In fact, let me do that explicitly because there may be a mark for that. So if those coordinates lie on C, we know that for the same value of t, the x coordinate is 4 and the y coordinate is 2. If I solve for the y coordinate, 2 is equal to 1 minus t cubed. That means that t cubed is equal to minus 1, so t equals minus 1. If I plug t equals minus 1 here, I do get 4. So at the point C, t equals minus 1. Okay. Using parametric differentiation, what that means is that dy dx is equal to dy dt over dx dt. So dy dt is equal to minus 3t squared. Dx dt is equal to 2t plus 3. And we want this at the point P, where t is equal to minus 1, over 4 at P, where t is equal to minus 1. So if I plug in t equals to minus 1, I get the gradient is minus 3/4. And we know the coordinates of the point are 4, 2. So then we can just use the equation of the straight line. Y minus y1 equals gradient x minus x1. So multiplying both sides by 4, 4y minus 8 is equal to, and multiplying the minus 3 into the bracket, I'm going to get this, and moving it all to the left-hand side, while moving the numbers to the right-hand side, I get 3x plus 4y is 20. Great. It's used to model the profile of a slide at a water park. Units are in meters, with y being the height of the slide above water level. Find, according to the model, the greatest height of the slide. So that's the greatest y in this interval. The greatest height is clear for 1 mark, I think is correct answer only. The greatest height is actually very clearly going to be when t is equal to minus 2. So when t equals minus 2, y is equal to 1 minus 8, which is 9. So I'm going to say 9 meters is my answer there to be. Okay, so 11. So this looks like it could be done with a graphing calculator, which is why they say absolutely under no circumstances. So finite region bounded by C, x equals 1, y x-axis, okay. Find the area of A. Great, this should be fine. I say that. Yeah, that should be fine. It's just the integral of that thing between 0 and 1. So it's the integral from 0 to 1 of 8x squared e to the oh no, no, don't make it a double by parts. Why are you giving me a double by parts? Okay, so making sure you know all of your integration rules. My context clues here are that I have polynomial times exponential. This is whenever you see a ln x or an x or an x squared, that indicates you might be by parts, where this thing is my u. So I'm gonna, oh god, this is gonna be so tedious. All right, pray for me. So for the first by parts, u is equal to 8x squared. U primed is equal to 16x. V primed is equal to e to the minus 3x, which means that V was minus a third e to the minus 3x. So integrating once. By parts for multiplication, yeah, it's sort of like a reverse product rule. Yeah. So the integral becomes uv, so minus 8 thirds x squared e to the minus 3x between 0 and 1. It would be minus the integral from 0. I'm just going to be explicit about this. So 16x times minus a third e to the minus 3x dx. So it would be minus 8 thirds x squared e to the minus 3x between 0 and 1. I'm going to take the 16 over 3 out because that will turn that into a plus. So plus 16 over 3 integral 0 to 1 of x e minus 3x dx. And then would you look at that? This guy, you need a new by parts where u is equal to x, u dash is equal to 1, where v dash equals e to the minus 3x. Would you look at that? V is equal to minus a third e to the minus 3x again. Not even satisfying. I'm gonna do this here and then bring it all down. So it's minus. Also, guys, if you got any feedback on like how it looks on the screen, obviously it looks good for me while I'm solving it, but the way it formats on your screen may not be as optimal. So definitely let me know if you want me to zoom in or anything. So plus 16 over 3 into, oh God. All right, uv at a minus a third uv. Okay, how do I make sure I don't make an execution error? I'm good. First of all, I'm going to just rewrite this, right? So it's minus 8 over 3x squared e minus 3x. Okay. And that's between 0 and 1. We have a plus 16 over 3 into minus a third x e to the minus 3x, also between 0 and 1. So 16 over 3. So it was 16 over 3 into uv minus, so I'm going to do minus 16 over 3. You can see I'm slowing down just to make sure execution, nothing gets lost. The integral from 0 to 1 of minus a third e to the minus 3x dx. And that comes from u dashed v. So it's, let me just make sure. Okay, so 16 over 3 into, integrate that up, good. Minus the integral 16 over 3, this is all correct, I think, cool. Do I teach offline? Yes, I do teach offline. Now, if I bring this all into one thing, minus 8 over 3x squared e to the minus 3x minus 16 over 9x e to the minus 3x. This becomes, it would be a plus 16 over 9. No, I'm just going to do this in steps. So plus 16 over 9 into minus a third e to the minus 3x, 1, 0. I can bring all of this together in one big limit. Now, ideally, I would have a nice, really elegant solution path here, but I don't mind showing you when it's a genuine struggle because it shows you guys what to do in similar situations. So now we can plug in. Now we're kind of home free. So when I plug in 1, I get minus 8 thirds e to the minus 3, minus 16 over 9 e to the minus 3, minus 16 over 27 e to the minus 3. Great. Subtract off when I plug in 0. That is 0, that is 0, that is 16 over 27. E to the 0 is 1. Cool. So therefore, and I want it in the form of constant plus b e to the minus 3s. So it is 16 over 27 minus 8 over 3 and 16 over 9 and 16 over 27. So minus 136 over 27 e to the minus 3. Final answer. Thank God that question is over. Double by parts is so, it's not even fun. There's not even payoff. It's just tedious. Partial fractions, less tedious. Okay, so 12a, is this going to be nonsense? Because this looks like it might be nonsense, but I need the space. So what's a good way to get rid of silly mistakes? I'm in year 13 and averaging 90 to 95 in pure papers, but still make dumb mistakes and sometimes barely finish in time. Watch to see what I do. Like, the best thing you can do, you're going to make mistakes because you have a human brain. So what you need to do is check your work really well. If you can get your speed up to the point where you're getting to the end with enough time to check, then you can use the checking techniques that I'm about to give you when I finish my run. You can also keep track as you do all your past papers, keep a literal log of all of your execution errors so you know what they are. That's why I know sign errors galore with me. So I know I can anticipate, let's have this conversation. So I can anticipate when I'm about to make an execution error because I've done it before. So the analogy I like to make is it's like doing like a Super Mario run where I say that like what's the one with the cars? That one, because games. Super Mario Kart, that's the one. All right. So like Super Mario Kart, where you've got like sort of like a Rainbow Road situation where you know you've got this corner where you always fall off. Eventually you're like, oh, that corner's coming, and you stop, you slow down, you're like, all right, gotta get around it, and then you're fine. And then you can start kind of getting back into the flow. And you learn to do that. You learn to do the gear shift. Yeah, I'm talking about Mario Kart because do you know what? Because I'm the king of metaphors, is why. So yeah, when you can kind of anticipate, like when you've made the same execution error several times before, you build a relationship with it, and you kind of say, all right, like you can anticipate it. So that decreases your chances of making the execution error in the first place. And if you use good checking techniques, then you'll be able to pick up the ones that fall through the net. So here we're expressing this as partial fractions. So it was 1 over v into 25 minus v, I believe. Yeah. Okay, so that is going to be, let me zoom in just a touch. So that will be here we go, a over v and b over 25 minus v, which means that 1 is going to be equal to a into 25 minus v plus b lots of v. I defend you complain without exception after every paper that he made a sign error. It's just because, like, well, no, but using the checking techniques I give you, it'll be much easier to spot where those sign errors are so you can pick them up. Do Mattis math. The thing with Mattis math is it's very difficult and not necessarily true to like the syllabus. Maybe for a bit of fun, if we have time for that. Now, I like a good substitution method. So when v equals 0, we have 1 is equal to 25a plus 0. So a is equal to 1 over 25. And when v equals 25, 1 equals 0a plus 25b. So b is 1 over 25, which means this thing is 1 over 25v plus 1 over 25 into 25 minus v. Is that right? Is that right? I don't feel right. Yeah, it might be right. Is that right? 25 plus v. I don't feel right. Oh, no, it's right. Huh. Okay. Cool. So I've expressed it as partial fractions. ESAT was fun. Respect on its name. So ESAT is literally the most fun exam I've ever. Well, granted, I never had to sit it under pressure, but it's like genuinely the most fun I've ever had in a live solve. Which is probably why you guys think it's the worst thing ever. So we have an initial volume of 20 microliters. Okay, so I'm going to rewrite this on the next page. So dVdt is equal to a tenth v into 25 minus v. The reason why that's relevant is because this is now a separable equation. So the integral, we can bring the v25 minus v down here, and we can keep the tenth where it is. Always keep the tenth where it is. Any constant should stay put in these. And so when you integrate that, that becomes the integral of 1 over 25v plus 1 over 25 into 25 minus v, as we found from the partial fractions. So what you get is, this guy is going to integrate to ln v over 25. This guy is going to be minus ln magnitude 25 minus v over 25. The reason I did that is because of ax plus b form. Normally a constant, 1 over a constant, when integrating with respect to that constant, would just give you ln of the constant. But here we have ax plus b form, where we have to divide by a, which is minus 1. Both of them are over 25 because I sort of took out the 1 over 25. So this is equal to t over 10 plus some constant. Now, we also know the initial volume is 20, where I think v is measured in microliters. Yep. So when t equals 0, v equals 20, this will enable us to work out c. So t equals 0, v equals 20. That means that ln 20 all over 25 minus ln 5 all over 25 is equal to 0 plus c. Now, when you're subtracting lns or any sort of log, you can divide the arguments. So that becomes ln 4 over 25 is equal to c. That means that find the time taken in minutes for the volume of the plant to reach 24. That means that, kind of suspicious of how this is going, but, oh, so for the time taken for the volume to be 24, okay. So what that means is ln v over 25 minus ln 25 minus v over 25 equals t over 10 plus ln 4 over 25. I'm going to multiply by 25 because no to all of this. 25 minus v is 2.5 t plus ln 4. Now we want where v is equal to 24, and we want to find the time where the time is measured in hours. Oh, danger, danger, danger. So let's plug in v equals 24. So that would be when v equals 24, we have that ln 24 minus ln 1, which is 0, is 2.5 t plus ln 4. So ln 24 minus ln 4 equals 2.5 t. Dividing the arguments, ln 6 is 2.5 t. T equals ln 6 over 2.5, which is, let me see, ln 6 over 2.5 is 0.7167 hours. And then if I use my fancy little button, the one that looks like this on my calculator, it tells me that is 43 minutes and 0.13 seconds. So I found that time. Now let's solve it for v. So let me take that. Let me see if I can do this quickly without having to spill over a page. So by combining the luns, in fact, let's get all the luns over to one side. So ln v minus ln 25 minus v minus ln 4 equals 2.5t. So ln, combining all the arguments, so we have v over 4 into 25 minus v equals 2.5t. Computer is straining. I'm wondering if I'm just like overloading it. Do I have like a million tabs open or something? Like what's happening? I mean, I do. Maybe okay. So I've closed a bunch of tabs. Maybe that'll like help it calm down. So what that means is that v over 4 into 25 minus v did not help it calm down equals e to the 2.5t. All right, now this is going to spill over. So let me rewrite that. So v over 4 into 25 minus v equals e to the 2.5t. And we got to rearrange for v. First things first. Let's multiply out 100 minus 4v e to the 2.5t. Okay, so that is equal to 100 e to the 2.5t minus 4v e to the 2.5t. Bring all the v's over to one side. Take out the v as a common factor. And once done, divide through. Now I'm going to rearrange this into this form because I have a feeling they don't want it in that form. Good. I'm going to have to multiply the top and the bottom by e to the minus 2.5t. And when I do that, I get 100 over 4 plus e to the minus 2.5t. Is that the form they want? I'll just, yeah, close enough. So I'll just make it explicitly in the form they want. E to the minus 2.5t plus 4, and I'll call that a day. Okay, so then we got 13. So far, so unfun, but 50 minutes left. So p equals stuff, right? This is going to be a log. I'm going to kind of annotate this here because it's simple enough. Whenever you get this, the first thing you do is take logs of both sides. So and use your log laws. So log p is equal to log of a b to the t. Using your log laws, that is equal to log a plus t log b. This is of the form of a straight line where the gradient is log b and the intercept is log a. So what that means is if log b equals 0.0054, then b is equal to 10 to the power of 0.0054, which running in my calculator yields me a result of 0.0054. It is 1 point, so 3 decimal places, 0.013. And here, a would be equal to 10 to the 0.81, which would be equal to 10 to the 0.81, 6.457. So those are my a and my b. interpret the value of the constant a. So that is the initial value. When t equals 0, p equals a. So it means initially, so when t equals 0, so initially, the population would have been 6.457. So in other words, initially there were 6.457 billion people. So that's the interpretation in the language of the question. So the human population was 6.457 billion people. Now the value of the constant b, I'm going to interpret that as a 1.3% annual increase in population. And the reason for that is because that is that multiplier, 1.013. If you're multiplying by 1.013, that is the same as a 1.3% increase. So for using this to estimate world population in 2030, well, t is the number of years after 2004, which is such a weird start point. But 2030 minus 2004 is 26. So the first one is 2005, that tracks. So we want to plug 26 into this model we have. And the model we have is P, in fact, now I'm actually going to start writing this out. So P is 6.457. I am still watching the chat, and I'm still seeing this ESAT slander, and I will not stand for it. Times 1.013 to the power of 26. So 6.457 times 1.013 power 26 is 9.03 billion. Comment on the reliability of the answer to C. I'm going to say they love this for the exponential modeling stuff, but like may not be reliable. Predicts infinite growth. And in reality, there may be limitations on food or space. Honestly, that is a fair shout out. Someone says doing the ESAT outside of the exam and doing it in the exam is like two completely different things. Correct. 0 lies detected. So yeah, honestly, you get that. The stakes do change it. Predicts infinite growth, I should have said. In reality, may be limited by food or space. Okay. Please be done soon. This has been oh no, circles. Okay, I'm back and I'm so invested now. Oh, I'm so on board. So on board. Right. So this first one, I'm just going to rewrite it. X squared, but I'm going to rewrite it grouping my x's and y's. Y squared plus 14y plus 33 is 0. Which means x minus 3 squared minus 9 plus y plus 7 squared minus 49 plus 33 is 0. X minus 3 squared and y plus 7 squared is equal to 49 plus 9 minus 33, 25. Which means for part A, the coordinates of the center are 3 minus 7, and the radius is 5. a different circle has a new center and a new radius, given that they intersect at two distinct points. Now, this is such an interesting question. So, I'm going to sketch this out. We know that the first one has 3 minus 7. So I'm going to put that roughly there. The second one is at minus 6 minus 8. So I'm going to put that roughly there. We know that this guy has a radius of 5, which means it crosses the x-axis, but crosses the y-axis, but does it not make it back up to the x-axis? Now, in order for this second circle at minus 6 minus 8 to intersect twice with this one going through 3 minus 7, you got to think about the limiting case. Limiting case number 1 is the circle is very small. When the circle is very small in the limit, it will touch here once. If the radius is bigger than this radius, then it will touch twice, unless it gets too big. If it gets too big, the circle will be too big and it will absorb this circle, right? So in the limiting case, it's a big circle, which again touches this circle exactly once. Now, what's going to happen? Drawing a totally straight line here. Let me keep it going through. So we know this radius is 5. So this distance, so this point here I'll call A, this point here I'll call B. These distances are both 5. We know that the radius is K, right? So let's think about the distance between these two centers. That distance would be the square root of 9 squared, which is the change in x, and 1 squared, which is the change in y. So it would be root 82. That is the distance between the centers. So the minimum k would be root 82 minus 5. In other words, the distance between the centers minus this 5. That's the smallest k can be. And the biggest k can be is root 82 going from one center to the next, plus a further 5. And so those are the ranges of k. Writing in set notation, you guys should do that. I just don't think the mark is worth it. I hate set notation, and I will never, ever do it. Luckily, when I was doing A-level, they didn't demand it in the same stupid way that I just think is silly. So I'm just going to write it like this and have my fun. Sue me. Okay, so 15, is this the final question? Yeah, okay, cool. And then we get into the checking, and we got 40 minutes left, so I'm feeling okay about it. Granted, I've also taken some time to talk, so I'm not going to go strictly to time, but cool. Implicit differentiation. I will write this out. So x plus y cubed equals 3x squared minus 3y minus 2. I quite agree. Implicit differentiation is gorgeous. Absolutely lush. So I'm going to do implicit differentiation. For this one, I'm going to do d big, d small. Or rather, like, brain just buffered so aggressively hard right there. So this is going to be chain rule, where it's going to be 3x plus y squared times the differential of the inside thing with respect to x, which is 1 plus dy dx. And then on the right-hand side, when I differentiate with respect to x, I get 6x minus 3 dy dx, and that goes to 0. We need to rearrange this to make dy dx the subject. Which looks so imaginably unfun. No, this is going to be fine. So it's going to be 3x plus y squared plus 3x plus y squared dy dx to separate those out, because that will enable me to get all the dy dx's to one side. I should also divide everything by 3 to make it more manageable. When I do that, I will get x plus y all squared lots of dy dx, plus another one lot of dy dx by adding that across, and that will equal to 2x minus an x plus y squared. I can then say dy dx bracketed into x plus y squared plus 1 is 2x minus x plus y all squared. And then dividing through, I have my dy dx is equal to 2x minus x plus y squared all over 1 plus x plus y all squared. Cool. The point P lies on C. Show that the normal to C at P. So the normal, so let's find at point P what the gradient is. So dy dx, it's where we have x equals 1, y equals 0. Just make a note of that. Making sure I didn't, yeah, that's good. So dy dx would be equal to 2 minus 1 plus 0 squared all over 1 plus 0 squared. Now that is 2 minus 1 all over 1 plus 1, which is 1 over 2. Great. That is the gradient. That is the gradient of the tangent. So therefore the gradient of the normal would be equal to minus 2. And plugging in, so y minus y1 equals mx minus x1. So y equals minus 2x plus 2. Great. So that's I'm feeling good about how this question's gone so far. Prove that the normal to C at P, which is this, does not meet C again. So prove that this thing does not meet C again. Well, let's talk about when it would meet C. If it does meet C, that at any point of intersection, both equations are true at the same time. So in other words, this is simultaneous equations. Now, we're going to take that y, put it into the equation for C, and try and see how many solutions that has. If it doesn't meet C again, we've just shown it only intersects at one point, so I expect only one solution. So plugging that in, let me just write both out again. So on the first one, sum cubed equals 3x squared. So sum cubed equals 3x squared, was it plus or minus? Minus 3y minus 2. And we had the equation y equals minus 2x plus 2. And these are going to be what we try and solve simultaneously. So plugging that in, so x minus 2x plus 2 all cubed equals 3x squared minus 3 lots of minus 2x plus 2 minus 2. I'm just going to do this very explicitly. So this would be 2 minus x all cubed, 3x squared plus 6x minus 6 minus 2. Okay, so let's expand this out. So that would be minus x. No, I don't like how I'm doing this. I'm instead going to do it from just the front facing. So that would be 8 plus 3 2 squared minus x plus 3 2 minus x squared minus x cubed, 3x squared plus 6x minus 8. So 8 minus 12x plus 6x squared minus x cubed is 3x squared plus 6x minus 8. So 0 equals, bringing that across. Well, actually, I wonder if I should have No, this will be fine. X cubed minus 3x squared plus 18x minus 16. Now, we know one of the solutions. We know one of the solutions is when x is equal to minus 1, which means when x is equal to 1, so x minus 1 should be a factor. I'm not going to do the long division. I have the ability to do shorthand, so I'm not even sorry about it. So you could do the algebraic long. Fine, I'll do the algebraic long division. So x minus 1 going into a bunch of nonsense. Plus 18x minus 16. Put in x squared, x cubed minus x squared, because I'm meant to make this more accessible. So that's minus 2x squared, because I'm minus turns that into a plus 18x. So minus 2x, multiply this by minus 2x, you get minus 2x squared plus 2x. And if I knock that off, I'll get 16x minus 16, and that's where you get your plus 16. For a bit of fun, I encourage you to go sort of by inspection and see if you can build up that skill. Yeah, I agree with I don't really go tables. Like for me, I either go long division or inspection. Now, let's look at this guy. And let's look at the discriminant on this guy. B squared minus 4ac is minus 60, which is less than 0. Therefore, no solutions on this guy. And therefore, only one solution at x equals 1, and therefore no further intersections. Right, so I've done my first run. What I really want to demonstrate now, theoretically, I have 30 minutes on the clock. In practice, I would have had a bit more time because I've been stopping and chatting and explaining things. But what I'm going to do is, again, like I did last time, let's demonstrate effective checking technique. Because I guarantee I've made some execution errors, but I want to go through the best way to check to find where those execution errors are. So in the first instance, there's not really a way of checking these first ones. You just have to this is one where you do have to redo it and make sure you didn't make any silly mistakes. So yeah, that is 12x squared minus 14x plus 5. That's correct. Differentiate again, 24x minus 14. Good. What I'm going to do to check is to take the answer I found of 7 over 12, plug it back in. So 24 answer minus 14. I can confirm that's where d squared y dx equals 0. Good. One I feel good about. 2. Show that they repay it in month 12. So in month 12, it's 290. That's what I got. Great. Show a quadratic. I found the quadratic. Great. Hence, find a value of n. Well, I've actually already done that. So I plugged in n equals 36, and I found 8100. That is the first month where they actually hit. Ooh, someone asked what books I recommend. Depends. Do you mean academic books, general nonfiction, or general fiction? Happy to answer that when you specify. So we've got the quadratic, and I found the value of n. The first month where the loan gets paid, you hit the 8100, and therefore the loan is paid off, is month 36. So n equals 36. Okay, I'm feeling good about that. This one. I'm laughing so hard because someone says, oh, what books do you recommend? And then someone commented, Wuthering Heights will help you with your math 100%. Goodness. Okay. This I will explain, but I will explain when I'm sort of analyzing. In terms of my checking, let me just make sure that has moved 3 to the right. So that's right. This is halved the x, so that's right. That goes to minus 3, and then I triple that to minus 6, add the 5, minus 1. Yeah, this is all good. Overall, best of each category. I will say I don't read as much as I should / used to. Academic books. Academic book. I really did like, if you're into chemistry at all, Why Chemical Reactions Happen is great. General nonfiction. What's good? There was a book called Sociopath I found very fun, going through the life story of someone who was a diagnosed sociopath and how they kind of came to terms with that and integrated that to sort of become a therapist who helps other sociopaths. Very interesting. Fiction, I did really enjoy both the Millennium Trilogy, which is the Girl with the Dragon Tattoo series, and A Little Life, which is, I cannot, okay, if I'm going to even mention A Little Life on this channel, A Little Life is the most adult book you could ever conceivably have. There is every conceivable trigger warning on it. So heavy, so dark, so not for everyone. If you have any sensitivities about reading a book, do not make this the book you pick up. If you want to be ripped clean in two, then A Little Life is for you. Integrated. You say that. Talking about integrated, that's an actual therapy term, a proper integration of all your parts. And I know that because I was actually initially training to become a therapist, which is why I became a tutor. And then decided that therapy was an overcorrection. Because I decided I like bullying teenagers instead. Much more my calling. Right, so how would I check question 4? Show that this thing, well, I did find that this thing, so that feel good about that. Hence, find the value of k. Let me just plug my value of k back in and show it got me a correct answer. So 4/3 equals, and then 6 answers squared minus 5 answer minus 4 is 0, so it works. Find the value of this thing. Well, U1 is 6. Let me also just plug my 4/3 back in. So 6 answer minus 5 is 3. We know that U3 is minus 1. So 6 plus 3 minus 1 does give me 8, so I feel good about that. The therapist, a professional bully pipeline. Completely. Right, what I'm going to do here to check this is I'm actually going to try a small angle. So I'm going to convert my calculator into radians and pick 0.01, submit that, and then I'm going to do answer tan to answer all over 1 minus cos 3 answer is, so for instance, so here, when theta equals 0.01, I get a calculator value of 0.4445. And as we know, 4/9 is 0.4 recurring. Therefore, I'm correct. Good. I know I did nothing wrong. Here, d big, d small, that is that. The next, that is that. Show it satisfies this equation. Professional answer checking technique is to draw the graph of whatever is going on with your graphing calculator. Yes, if you have a graphing calculator, feel free to draw that as well, depending on the question. Now here, setting these two equal to each other, I did get the equation. And here, you kind of just run it. Like, there's not much checking. You just rep it. So 0.6, all I can do is just redo it and get 1 minus 2 ln answer all over 4. And just press the answer button until I get tired. And just make sure that eventually I get to... Yep, it is definitely 6706. Great, so I feel good about that. So far, so good. Nothing too silly. Now this guy. All right, let me see if I can do this one again properly. Okay, in the interest of time, though, let's pretend that this is the time. When you do enough of them pure papers, it just gets very samey. Well, this is when you start working on speed and accuracy. So I was able to, because I did like every available past paper, but it was still like keeping myself fully engaged. The real exam is going to feel more stress than your practice, and the way to artificially induce that stress response is to give yourself a time limit. So instead of giving yourself 2 hours, see if you can solve the paper in 1 hour 15, because that time pressure will force you into the same sort of stress state that the pressure of the real thing will. So you can practice in the mindset that you'll be performing the real thing. And you'll be working less on conceptual stuff, more on execution consistency and exam technique work. So A, I did manage to prove that. What I'm going to do for the second part is to substitute my answers in and make sure I get the same thing. So converting my calculator back into degrees, or else I will blow the whole thing up, is angle unit degree. Right, so 17.6 equals. Great, that's stored as my unit there. I'm going to type it into here, which is going to be quite complicated. So 1 over, cosec is 1 over sine of 2 answer. That's cosec minus 1 plus 1 over sine 2 answer bracket plus 1 minus 1 over tan 2 answer cos 2 answer. I should get something approximating 0, and I do. So that first one feels good. Let me input the second value and make sure that also works. 72.4 equals. I'm going to plug it back in the same way. So typing into my calculator, 1 over, this is 1 over sine 2 answer minus 1 plus 1 over sine 2 answer plus 1 minus 1 over tan 2 answer cos 2 answer is, again, a very, very small number, so it should be 0, and it basically is, which means these two answers are correct, and I feel good about it. 9. Again, are they going to want this? One of my friends would just refuse every attempt I made at informing him of proper exam technique. Guy would insist on going through the paper linearly without skipping or watching the clock. Oh, no. Nope. Do not stand for that. There are many times here where I should have demonstrated good exam technique by skipping. What I'm going to do, actually, is I am going to try this the other way I said, just to corroborate that it gives me the answer I want. So let me redo A, actually. So A, I could have said that x is equal to ax squared plus bx plus c, which means that dh dx is 2ax plus b, which equals 0 at x equals 9. Which means that 18a plus b equals 0. I would also have the coordinates so 0, 2. So 2 equals c. Love that. And we also have 0.8 and 0.8 equals a into 20 squared and b into 20 plus that 2. So it's 400a plus 20b plus 2. So in other words, 400a plus 20b equals minus 1.2. And 18a plus b equals 0, which means that multiplying this by 20, 360a plus 20b equals 0. So 40, by subtracting that equation from the top equation, 40a plus 0, that minus that is minus 1.2. So a equals, divided by 40 equals, great, minus the minus 0.03 that we already found. And then b is equal to 18 times 0.03, which is 0.54. So therefore, it's minus 0.03x squared plus 0.54x plus 2, which I'm hoping is what I would get if I expanded all of this out. So I would get certainly the minus 0.03x squared. And then if I multiply that, so 0.03 times 18, so we get plus 0.54x. And then, oh, this will be interesting. Let me see. So then it would be plus 81. So it would be 4.43 minus 81 times 0.03 is 2. Yeah, these are definitely the same thing. So good, I definitely got that model. One limitation of the model, I don't care about words. Let me plug in 16 into this equation and see what I get. So minus 0.03 answer squared plus 0.54 answer plus 2. I get 2.96, which is still too high. So I feel good about this question. How would I check this? Well, it's a show that. You don't really have to check a show that, because if you get it, then you get it. Find according to the model the greatest height of the slide. And again, I feel good about this because that will be the biggest y, and the biggest y will be when t is equal to minus 2, like it just will. The best thing I can do maybe is plug that in just to verify, but 1 minus answer cubed, yeah, it's 9. Like it is 9. And then making sure that the y stands for meters. Units are in meters, so the greatest height is 9 meters. Great. This guy. So the integral of this guy between 0 and 1, there's not really a way to verify this unless you have, okay, I will say if you have a graphing calculator at this point, you should just put that in and make sure you get the same value. So you would type that in to get a numerical value, check it against your graphing calculator, make sure that the results are the same. In the meantime, I literally cannot be bothered to check this. No, let me find, okay. So integrate up, differentiate down. Good. Taking that out for sines. That, okay, then this, so plus 16/3 into, integrate up, minus 2, right? That's correct. So that is good so far. Take the minus, okay. And then you integrate that. Yes, this feels good. So this is all the same, and then that comes out, that feels good. Plugging in the 1, these all just become e to the minus 3s. Plugging in the 0, these 0 out, that just becomes that. Okay, let me just run this again. So 8/3 plus 16/9 plus 16/27. Good. That's all negative, that many e to the minus 3s. Those negatives cancel to make a positive. I feel good about this. Okay. Express this in partial fractions. What I'm going to do is I'm actually going to plug in a random value on both sides to make sure. So let's say v equals 17. So 1 over 17 into 25 minus 17 gives me 1 over 136. So they plug 17 into the right-hand side. So 1 over 25 times 17 plus 1 over 25 into 25 minus 17 is 1 over 136. These are the same. I feel good about that. The volume of the plant. So what I'm going to do now is obviously plug the time in to my V and make sure I get 20. So I said that V is equal to stuff. And of course, I forgot my T. So that's T. So the time that I found is 0.7167. If I plug that into my model, I get 100 over e to the minus 2.5 answer plus 4, which gets me 24. So I'm feeling good about both the model and that time, that answer to B being when it is 24. Yes. This all feels good. Okay. Checking 13. How would I do that? I wouldn't really do that. I would just rerun this and make sure 10 to the 0 point. Just rerun those and that's fine. Interpreting them, that's fine. Plug it back in, that's fine. So this is more, there's nothing special here. You just redo it, basically. No special checking technique required. So here, center radius look good. I've swapped the signs. Yeah, that's good. And I'm sure my technique for B is correct. That the distance between those 2 points, that's 9, that's 1. So that is root 82, certainly. So root 82 minus 5, root 82 plus 5. I'm sure that's correct. Nothing special for the checking. Now here, well, I used A to get B, which was a show that, so no checking required. And I did use, I think I'm feeling good. So I even have 12 minutes on the clock, so I can stop that. So I'm feeling good about the checking. Let's see if I did anything stupid now. I also never once used the formula book. Go me. Mainly because I'm very, very confident on my by parts and my like special integration and differentiation rules. So let's just make sure I didn't do silliness and then go back and explain what I was thinking in some of these questions. So here, 12x squared minus 14x plus 5, 24x minus 14, 7 over 12, good. Let's show a thing. You plug it in, you get it. Yep, great. For B, you get it. You rearrange it, good. And notice how I checked, I noticed that I was like, wait a minute, I'm not getting a quadratic, which is how I spotted that n to put back in. So that's fine. Let me see. You get 2 answers and you just say it's n equals 36. Perfect. It could have factorized. I didn't spot that. I used the formula, whatever. Here, okay, let me actually bother explaining this now. But first, let's make sure I was correct. 5 minus 2, 3 over 2 minus 2, minus 3 minus 1. Great, perfect. Okay. The way I think about graph transformations, I won't write out the language of what each transformation does, but in my head, this is how it works. So we've got f of x plus a, f of x plus a f of x, f of a x, minus f of x, f of minus x. So in this one, y goes to y plus a. In this one, x goes to x minus a. Here, y goes to a, y. Here, x goes to x over a. Here, y goes to minus y. Here, x goes to minus x. Now, you can see that in each case, if it affects y, it does exactly what you think. Adds a, multiplies minus 1. And if it affects x, it does the exact opposite. Subtract a, divide minus 1. But if you learn the effects of these transformations, this is what I was doing in my head in order to get these results. So for the first one, that is of this type, where x minus 2 would go to x plus 2. So 3 plus 2 is 5. 2x would go to x over 2, so I divided my x coordinate by 2. And then I did this one sequentially in exactly the same way. where I first made the then considered the negative x transformation, and then took the y coordinate multiplied by 3, added 5. So not too bad if you've really got a good lick on your transformations there. Now 4, you plug it in, you get it, you're fine. You get 4/3 and 8. Nothing too bad in that question. Nice sort of show that. Perfect. Perfect. 4/9. Great. Got it. Here's some nice differentiation. So 8x e to the stuff and 8 over x. Perfect. Set them equal to each other. Rearrange. Got it. 7109. 6706. Perfect. Nothing too bad there. Oh no, this one. Let me... This one bothers me so much. Before I look this up, I want to try and redo this and see if I can do it using the proper algebraic method instead of like the intuitive, I can just see it in my mind's eye method, because that don't feel good. How should I have done this? Oh, of course, I'm being an idiot. No, but am I being an idiot? I might be being an idiot. Because these lambdas should not have been the same lambda. Where am I from? I am originally from New York and moved to the UK when I was 11, hence having a very mixed accent. No, these are the same lambda, though. Did not see New York coming. No, I am just going to check the mark scheme. I think watching me faff around isn't going to be very fun for you guys. So here, 393, perfect. So the answers are 8, 15, 11. Great. And 4, 3, 7. Perfect. How did they do it? There's multiple methods. So I kind of did it by inspection. What did they do? OP is OA plus 2 plus OA. No, that's exactly how they did it. They just sort of did... Yeah, they just did it by inspection as well. They just sort of said, yeah, it'll clearly... Oh, that's so interesting. Yeah, okay, this is what I was attempting to do, because this felt more rigorous than just sort of seeing in your mind's eye that it's going to be when lambda is 2 and lambda is 2/3. So what was this more rigorous method? Yeah, I just didn't... It's because I took out the factor of lambda and lambda minus 1, though. Because that is minus 3, minus 9. I felt like I could have taken out a factor of lambda. Oh, I'll tell you what it is, though. Maybe I was right. No, I'll tell you why. No, I could have... Okay, guys, I was totally there. But it's... Yes. Okay, so it's because the magnitude is the positive... Okay. Here's the argument. So I was completely correct. up until I think here, because what I should have done is to square them. So if I had said AP squared is 9x times 11, so 99x squared. And BP squared is 99 lots of x minus 1 squared. Sorry, that should be squared. Everything should be squared up. Then what I should have done is equated those two. So I should have said 99 lambda squared equals 99 lambda minus 1 squared. No, which only still gives me 1 lambda. Ah, come on now. Oh, but it should have been 4 lots of that. Oh, no, okay. We're back. Guys, we're back. Totally back. Because that should have been 4 lots of that. Great. So divide that through. Lambda squared is 4 lambda squared minus 8 lambda plus 4. So 0 is 3 lambda squared minus 8 lambda plus 4. From which you get 3 lambda. I think we said that would be minus 2. Yeah, and so lambda is 2/3 and lambda equals 2. So that's if you prefer a really rigorous mathematical approach. Ooh, my method for doing moments. Well, you will get to see my approach, sir, when I cover the stats and mech from this year. Hopefully, assuming that has moments. It depends on whether you're talking about moments in 1D or moments in 2D. Happy to show either. My biggest tip for you is to draw on any local distance. See you around, sir. Have a good rest of your day. Right. Yeah, 2D moments. Oh, it's so much fun, guys. Right, so my logic, if you want to follow my logic through here, I was close. But I just should have had everything squared up. And then it would have been fine. So that would have gotten me my 2 lambdas. I could have plugged the 2 lambdas back in, which is kind of what I did up here by inspection. But if you want a more rigorous reason why that should be a 2 and that should be a 2/3, this is why. Okay. Sweet. Won't be too much longer. Prove that. I did that. I'm so feeling good about that. Worthy answers. 17.6, 72.4. Absolutely. Question 9. I'm genuinely curious to see what they allow here. So this was the second way I did it. Would they have allowed vertex form? Great, I did it both ways. They totally allowed both. Great. One limitation of the model. Jen, again, really curious here. Air resistance. Okay. Okay. And then 2.96, not able to catch the ball. Perfect. Getting this all through. Hold on. 9. So 10. Yeah. So you, do all that. Minus 4/3. Plug it through. Get it. Fine. Good. Max height is 9. Perfect. No issues. Hear this integral. Guys, drum roll, please. Let's see if I actually made this through without an execution error. Oh, yeah. Nailed it. That was awful. I hate double by parts. But I managed to go through without making execution. Great. Love to see it. 12A. 1/25 is good. The time is 43 minutes. Good. And then in C, 100 over e to the minus 4t plus 4. Love to see it. Did I do it? Oh, guys! Oh, I did it! I did the stupidest of all the mistakes! Oh my god! Right. Okay. I have two pieces of exam technique. When it comes to math papers. Math technique number one. The second you think you're done with a part of the question, before you move on from it, reread it to make sure you've actually answered the question. Exam technique number two. The second you think you're done with the paper, the first thing you do before you check is to make sure you've answered every part of every question. Let's have a look at what I did again, because this happened to me in GCSEs, this happened to me in A levels. I answered parts A, B, and C, and then I thought I was done and moved on and did not see that there was a part D. This is a problem in these papers where they give you all of the questions, then all the answer space. I stopped at C, and so I do not get those marks because of stupid exam technique, because I didn't see it. Oh my God, I swear okay, story time. The exact thing happened to me in a mechanics paper in year 12 or year 13. I can't remember which one. Because that was back when we were doing ASs, so we didn't sit them all at the end. There was like this beautiful, like I remember the slope, and it was like some sort of Subadi thing with friction. There was a really complicated like A, B, and there was an A and a B and a really complicated part C, similar to what there was here. And then I just didn't see that there was a one line part D, which was worth 7 marks, until I was going through and checking, and then found it with like 2 minutes to go and didn't have time to do it. Honestly, and there was the fact, if I had just walked out of that paper and not known I missed a question, I would have been like, oh, I guess I did something wrong. But the fact that I knew I didn't see it, I wanted to just die, like spontaneously combust. And this is why, again, I do live solve so you can learn from my mistakes. Look how easy that was. I got to the end of C. I thought I was done. I was not done. And I didn't check that I had answered every part of every question. I didn't go looking for that. Bad exam technique. Do not be me. Be better than that. So the upper limit, the upper limit is going to be when t tends to infinity. I know that this bit will die away to 0. So it will just be 100 over 4, which is 25. So easy. Marks left on the table for absolutely no reason. And it's just like, I'm a professional in this, but that's how easy it is to do this, right? Watch other people make instructive mistakes and then don't be that guy. Oh, makes me so angry. Okay. But we're calm and we're in control and we're in, everything's fine. Everything's fine. So 1.013, 6.457. Can you do further math papers at some point? We'll see about that. If you're seeking, you shall find. I'm definitely worse at further math, mainly because like it's not asked of me as much, and it's so formula paper. We'll see. It may be that I like do a life paper, decide that I suck at it, and then take it down forever. But like I did with the TMUAs, because there are people who are good at TMUAs, and I was not one of them. But we could try. So it's the word population in billions. Oh, in 2004. I said initially, but I should have interpreted what initially meant. Initially means 2004. So again, if you're asking for interpretations, always restate it in the language of the question. Scale factor of the yearly increase. So it's a annual increase of 1.3%. Perfect. Answer which rounds to 9 billion. Love it. Not reliable since data. Okay. Apologies. I hate wordy bits. I always get the wordy bits wrong. So the data was only for 2004 to 2007. So it's not proper for you to extrapolate. That I actually should have known because of what's happening in the stat syllabus. So Paul was going very strong, guys. Here, I think I'm going to redeem myself. So r equals 5, and it's between root 82 minus 5 and root 82 plus 5. Square brackets k colon, because reasons, just know how to do your set notation. I will never, ever, ever be bothered, and you can count on that. That's a promise. I don't break a promise to you. So dy dx, this was a little more complicated. Yeah, love a good sketch. Boom. Okay. So here dy dx was, I did the second form, 2x minus the sum squared all over 1 plus the sum squared. Good. So B, I showed that. Great. And here you plug it in. You get to a point where you realize that the discriminant is 0. Not for this one, but for the next one. Yeah, perfect. Discriminant is less than 0, so no solutions, no other roots, and so the normal does not meet C again. Perfect. So that's how to do a paper, and also how not to do a paper. So yeah, this is why, guys, this is why. Those are the two things. Check to make sure you've actually finished the question, and then at the end, check to make sure you've actually found every part of every question, because otherwise it just burns. I think still going through, this was a paper. The first paper was much better for me showing you how to check your work. The second paper was much better for me just whipping myself for not finding all the questions. Every time I do a run, I think there's something to pick up. Look at the little mistakes I make in terms of execution and exam technique. And if you're trying to get from like up a grade boundary, or if you're already hitting the A star, how to get deeper into your 90%, that's what to do. It's all about your execution and exam technique to make sure you get every mark you deserve. So that's the main takeaway. The Discord server, I'm going to get live, and I'm going to go live some point later this week with another physics stream. That is likely to be, if I can actually get my calendar, wherever that is, that is likely to be probably Thursday evening. No, not Thursday evening. No, yes, Thursday evening. It's likely to be Thursday evening. But I'll make sure to populate that, and that'll be the first thing that goes up in the server. So in the meantime, look out for that. Work hard, have fun, and I will see you guys next time. All right, take care. Bye-bye.